Good morning. In this presentation, we will see together how to calculate the reactions in a beam. Strength of materials is a science that deals with the engineering methods used to calculate the strength, rigidity, and stability of structural elements in buildings and structures. Strength refers to the capacity of a structure and its compound to withstand a specific load without destruction. Rigidity is the ability of a structure and its component to resist the deforming effects of external loads without excessive deformation. Stability is the capacity of a structure and its component to maintain a given equilibrium position corresponding to the initial state of balance. We have to know directly applied forces. These include volumetric or mass forces primarily due to self-weight and surface forces represented by external actions acting on the body's surfaces. Among these surface forces, we distinguish distributed forces. They are classified into two categories: uniformly distributed forces and variable distribution forces. And we have concentrated forces. These are forces applied to the solid under concentration over a small area that can, as a first approximation, be approximated as a point or a line. We need to know the different types of supports. There are three types: simple support, rotation, and one displacement are free, while the other displacement is blocked. Double support, rotation is free, while both displacements are blocked. Triple support, rotation and displacements are blocked. Depending on the type of support restraint in a structure, we can identify the number of unknowns, and based on this, we have several types of structures. A. Hypostatic structure, also called unstable or mechanism. It's a structure in which the number of unknowns is less than the number of static equilibrium equations. Second, isostatic structures. The number of unknowns is equal to number of static equilibrium equations. And hyperstatic structures, the number of unknowns is greater than the number of static equilibrium equations. The hyperstatic degree of structures is equal to number of unknowns minus number of equilibrium equations. In the following diagram, there are two types of supports: simple supports and double supports. In the first double supports, we have two types of reaction: horizontal and vertical. In the second support, we have only one vertical reaction. To calculate the reaction, we need to apply the general principle of equilibrium. Sum of forces in the x direction is equal to 0. So we have one horizontal reaction is equal to 0. Next, sum of forces in the y direction is equal to 0. So Ra plus Rb minus Bq is equal to 0. Bq is the concentrated force is equal to the force distributed multiplied by the distance. So Ra plus Rb minus 3Q is equal to 0. Ra plus Rb is equal to 3Q. So Ra plus Rb is equal to 3 ton force. Knowing that 1 ton force is equal to 9.807 kilonewton, Ra plus Rb is equal to 29.4 kilonewton. So we have to announce. To solve this equation, we need to calculate the moment with respect to point A. The sum of moments with respect to point A is equal to 0. The moment is equal to the force multiplied by the level arm. So 2Rb minus 3 halves Bq is equal to 0. 2Rb is equal to 3 halves Bq. Rb is equal to 22.05 kilonewton. We have Ra plus Rb is equal to 29.4 kilonewton, and we have also Rb is equal to 22.05 kilonewton. So Ra is equal to 29.4 minus 22.05. Finally, Ra is equal to 7.35 kilonewton. I would like to express my sincere gratitude to everyone who takes the time to watch my video. Thank you in advance for your attention, and I hope you find the content informative and enriching. Thank you again.